Hello friends, I am here to say about some TST experiments and the logic gates. First, let us talk about the AND gate. AND gate performs logical multiplication, commonly known as AND function. The output is high when both the inputs are high. The output is low and when any one of the inputs is low. Let us see. And next, let us talk about the OR gate. And the next gate we are going to see is about the NOT gate. The NOT gate is known as an inverter. The output is high when the input is low and the input is low when the output is high. Let us see its operation. And the next we are going to see is about XOR gate. The XOR gate, the output is high when any one of the input is high. The output is low when both the inputs are low. And let us see the operation of it. And and let us see about the full adder combinational logic circuit. Let us see its concept. A full adder is a combinational logic circuit that performs the arithmetic sum of inputs. It consists of three inputs and two outputs. The full adder uses two XOR gates and two AND gates, and it also uses one OR gate. Let us see its implementation. Let us connect the logic gates and the inputs together. Yes, we have connected the inputs and the logic gates together. Let us see some example outputs. Yes, we have successfully done the implementation of full adder. The next thing we are going to see is about full subtractor. The full subtractor is a combinational logic circuit of including logical gates. In a full subtractor, the logical circuit should have 3 inputs and 2 outputs. Let us see the implementation of full subtractor. For the implementation of full subtractor, we need 3 inputs called as switches and 2 XOR gates, 2 NOT gates, 2 AND gates and only 1 OR gate. And also we need 2 outputs called as light. Let us connect the inputs and outputs together. And so let us see some example inputs and outputs of the full subtractor. Yes, we have successfully done the implementation of full subtractor combination logic circuit. The next thing we are going to see is about code conversion. First, let us design a code converter for BCD to gray code. The code converter consists of 4 inputs and 4 outputs. It is connected using 3 XOR gates. Yeah, let us paste some 4 inputs. Let us say something about binary to gray code conversion. The MSB of gray code will be exactly to the first bit of given binary number. Now the second bit of code will exclusive of the first and the second bit of given binary number. And the third point is about the third bit of gray code will be equal to the exclusive OR of the second and the third bit of the given binary number. Let us connect the input and the outputs together. Yeah, we have successfully implemented the code converted for binary to gray code. Next, let us see about the code converted for gray code to binary conversion. Same as we did for binary to gray code. It also consists of 4 inputs and 4 outputs, which are implemented using 3 XOR gates. Let us know something about gray code to binary conversion. The first point is talking about the MSB of the binary number will be equal to the MSB of the given gray code. And the second thing we should notice is, now if the second gray code bit is 0, the second binary bit will be the same as the previous or the first bit. And the third thing is, this step is continued for all these bits. Yes, let us connect the input and the gates and outputs together. Yeah, we have successfully implemented both the converters, both binary to gray code and gray code to binary. The next thing we are going to see is about code converter 2. It converts binary code into XS3 code. Let us see its implementation. It consists of 4 inputs and 4 outputs. And the logic gates we used are 2 OR gate, 2 exclusive OR gate, 2 NOT gate and 1 AND gate. And the next thing we are going to see is the inverse of binary code to gray code, that is, the gray code converts into an binary code. It also uses 4 inputs and 4 outputs. And the logic gates we used here are 2 AND gate, 2 NOT gate, 2 OR gate and 2 exclusive OR gate. We are seeing the implementation and the outputs of gray code to binary code converter. The next thing we are going to see is about design and implementation of parity generator. Parity generator is used to detect the errors and transmission of binary information. Let us see its information. It consists of 3 inputs and 2 outputs. It uses 2 exclusive OR gate and 1 NOT gate. We are doing some examples of it. The next thing we are going to see is about multiplexer. A multiplexer converts 4 inputs, 4 or many inputs into one output. It uses 2 selective inputs. The logic gates we used here are 3 input AND gate, 2 OR gate and 1 output OR gate. The next thing we are going to see is about demultiplexer. It uses one input and transforms them into many outputs. The logic gates we used here are 2 NOT gates and 4 3 inputs AND gate. This is the implementation of demultiplexer. We came to an end of this video, so thank you friends.